Right. Hi, everybody. Happy Friday. So, today we will continue to finish session 9.4. And then we will also go over the quiz solution and quiz mistake. And when is the exam? Monday. So Monday, I teach a applied trick in this classroom from 9 to 9:50. So if you don't have other class at that time, feel free to come early and start the exam early. Do you have a class at 9? Yes. Okay. And you? Yes. Oh, okay. Sorry. So you cannot come early, but it's okay. I'm more flexible about the time. If you want to have more time after class, you can like go to my office and you can spend more time. And yeah, you have okay. Yeah. Okay. So let's look at the quiz. So the quiz, I have already posted the quiz solution. Let's see. Yes. So this is the quiz solution. So a company is considering expanding their production capacity with a new machine that costs $73,000 and it has a project lifespan of 10 years. They estimate the increased production will provide a constant $10,000 per year of income. Money can earn 1.5% per year, compound continuously. Find the present value of the machine and round your answer to 2 decimal places. So remember the present value and the future value formula. The present value is the integral from 0 to the time. The time period here is 10 years. And we have this is the income stream, f of t, and then e to the negative rt dt. By the way, in this problem, the f is a constant number, 10,000. But in the exam, your f could be a polynomial or it could be a exponential function. Okay, everybody? So be prepared. And then r here, 1.5% is 0.015. So you apply everything into the formula. This is what you get. Okay? And when you integrate, 10,000 stays here, and e to the ax, integral is e to the ax over a. Right? That's why we divided by negative 0.015. And we evaluate from 0 to 10. It means we plug in t is 10 first, subtract. We plug in t is 0. And we know e to the 0 is 1. So if you type this in your calculator, you'll get 92,861 and 34 cents. Okay? And do we use the 73,000 at all? No. So usually the problem is, does it worth to buy this machine? And then you compare this guy and then 72,000. And you see, oh yeah, we earn more if we buy the machine. So then your decision is buy the machine. Okay? So yeah, the 73,000, we don't use it in our calculation. You just compare at the end whether we should buy the machine. Okay, this is number 1. Number 2, find all the second partial derivatives. And we first need to find the first partial derivatives, right? And here, fx, we have x is the variable and y is the constant. So therefore, 3l and y to the fifth, they're just constant. Leave it there. Derivative of x to the 8 is 8x to the 7. Okay, so we're going over the quiz. And that's fx. Fy is you treat x as a constant, and y is the variable. So 3x to the 8 we made here. L and y to the 5th. Do you see this is a This guy is you need to use chain rule with like a u is y to the fifth. The derivative of ln u is 1 over u times u prime. Okay, everybody? 1 over u times u prime. So therefore, here, 1 over y to the fifth times u prime, where we take the derivative with respect to y. Therefore, derivative of y to the fifth is 5y to the 4. And we can cancel the y to the 4. We get just 15x to the 8 over y. Is that okay, everybody? And actually, there's one more way that you can simplify. So, do you see this is ln y to the fifth? Let me open a Word document so I can write on it. So people not in the class can watch the recording. Okay, so let's use 9.4. All right. So today we see this one. Okay, let me see my.
Is your charger plugged in?
Thank you.
I almost forgot that.
Okay, yes, that's very important, isn't it? Okay, so got this and this. A lot of lines. I'm like making a surgery. Okay, so let me just open a new one. Okay, I can write here. So what was that? The quiz. Okay, so like this, and copy and paste here. So you can rewrite this. You know the ln property? The ln of A times B is ln A plus ln B. ln A over B is ln A minus ln B. And ln A to the m. You can move the m in front. You get m times ln A. Right, everybody? So you can actually move the 5 in front. So you get 3x to the 8 and 5 ln y. Oh, see? When you differentiate, so this is f. When you differentiate with respect to y, you just copy down 3x to the a and 5. What's the derivative of ln y?
No, 1 over 1.
Yeah.
So,
See? We don't need to use chain rule.
isn't that the common way to do it, to move the 5 in front of the ln? Because that's the way I was taught.
Yeah,
Okay.
yeah. Mm-hmm. Right. Okay. But if I change the problem to like ln y to the 5 plus 7, then you're not able to move. Then the common way is still like use chain rule. Yeah, because it works for other type of function. Okay. Yes. So this is fy, and then fxx is we look at f(x), we take the derivative with respect to x. So 24 and ln y to the fifth, they're like constants. So we leave them there. And by the way, this afternoon I have study session from 3:10 to 5. Yeah. And here, yes. So the derivative of x to the 7 is 7x to the 6. And so we get 168 x to the 6. Natural log of y to the 5th. And fxy or fyx, two ways you can do it. You can look at fx and you take a derivative with respect to y. And this is what I did. Okay, you take the derivative with respect to y. So 24x to the 7 remains there. And then ln u derivative is 1 over u times u prime. And then you get u prime is 5y to the 4, and they cancel. So you only get 1y in the denominator. Okay, or you can look at fy and take the derivative with respect to x. Then you see the y is like a number, leave it there, And the derivative of x to the 8 is 8 times x to the 7. And 8 times 15 is 120. Right, everybody? So you can do them like both ways. Fyy is, we take the derivative of fy with respect to y. And do we need quotient rule? No, because your numerator has no y. So you don't need to do quotient rule. But you can rewrite the 1 over y to be y to the negative 1. Okay? Then derivative 15x to the 8 remain there. And the power rule, move the negative 1 in front, and then y to the subtract 1 from the exponents, negative 2. So this is the answer. So far, so good, everybody?
Test is 25th.
Next Monday.
Next week.
Yes, next Monday. That's why today, study session, 3:10 to 5 p.m. Hope to see you.
I'm scheduling with the OSS.
Yes. Mm-hmm. Okay, and let's look at the quiz mistakes. So we learn from the mistakes. So hopefully in the exams, you won't make the similar mistake. Mm-hmm. Okay, so here, this answer is fyx. So you're taking the derivative of fy with respect to x. Mm-hmm. So this is fyx. So then you need to find fyy. So that's the mistake. Because this problem has like 5 points, so one partial derivative is like 1 point. Mm-hmm. Okay, and here, present value. Why do you get 10,000 over that? So why? You need to show me all your work. Okay, starting from the formula and then plug in. And by the way, you get this. It's only because f is constant. Okay, if f is not constant, you actually need to look at. By the way, if you have a t here, you need to do integration by parts. Okay, everybody? If you have t here, you do integration by parts. You let u be 10,000 t, and then this is the dv. Right, everybody? Integration by parts. If your f has exponential function, e to the something, then you combine those two exponential functions. Your exponents will be different. Mm-hmm. So yeah, we did different types of examples in class. So review all of them. Okay. All right. And yes. So fxy. So trick, one variable is the constant, the other variable is a variable. So we don't need product rule. Mm-hmm. Be careful. And here fx, no product rule. The ln y to the fifth is a constant. So we don't have this part. Okay? No product rule. Because this is like a constant. Treat it as a constant. So just copy that and then take the derivative x to the 8. Yeah, similarly, fy, the 3x to the 8 is like constant. Copy it down and differentiate ln y to the 5th. Okay? Mm-hmm. So when you do this kind of problems, make sure to slow down. Because if you get your fx and fy incorrectly, and then whatever after is gonna be, yeah. So please be careful and check your fx, fy multiple times before you continue. Mm-hmm. So remember, one variable is a variable. Other variable are constants. Constants. Everybody say constants. Constants, yes. So you might not need product rule. Okay, and here, let's see, here it was x to the, fxx, here. So you have 7 times x to the 6, okay? And then here, fxy, 1 over u times u prime. Don't forget the u prime. And then fyy, yes, that's correct. But then derivative of 1 over y is derivative of y to the negative 1. So it's negative 1 times y to the negative 2. Okay, so be careful. And here, so, okay, do not use this formula because this formula is only correct when your f is constant. Okay, everybody? This formula, I know sometimes your homework, you see the videos, they teach you different method than I teach. Because I hope to teach a method that works for all types of problems. But maybe, that's why I write down the solution of your homework. But your homework has some like videos. They might use some formula is only true in that particular example. So I hope that you can follow the method I teach you. So this is correct, but only in this example when the f is constant. Okay, so be careful with that. Yeah, use the integral. Yes, use the integral. Okay, and do not round your number here because then do you see the final answer is not as accurate as you. So leave it as the exact answer until the last step. So you only like plug in this in the last step. Okay, so type the whole line in your calculator at the last step. Then your answer is more accurate. Okay, yes. And then here, there's no 7 here. Okay, see, there's no 7 here. So, right. Okay. So small mistake. It's okay. Sometimes I make mistakes too. So mistakes are our teacher. We learn from it. Okay, and here, let's see, fy. Oh, don't forget 3 times x to the 8. And derivative of ln u is 1 over u times u prime. Okay, derivative of ln u is not ln u. So be careful. And fxx, the ln y to the 5th remains here. Okay, so let's see. Here, f of t is 10,000, not 73,000. So we didn't use 73,000 at all in this problem, in the calculation. Okay, so yeah, be careful. And again, the derivative of ln u is 1 over u times u prime. See, you're not alone. This is a common mistake. So we just learn from it and don't make the mistake again in the exam. So the quiz, I would say quiz is a small percentage, right? So it tells us, oh, I need to study that more to prepare for the exam. Okay, so if you didn't do well on the quiz, it's okay. We dropped 2 lowest scores and it's only 5%. But the exam is more percentage. Yeah. Okay, and then yes, this is fx, but how about fy, fxy, fx, and fyy? So right now I set up my quiz is unlimited attempt. So if you need more time, if 30 minutes is not enough for you, feel free to start a new attempt right away.
Oh, I think that's mine.
Yeah, so answer all the
I had to pick up my daughter, and I thought that wouldn't be fair that I'd be going for 40 minutes. And then come back.
Okay, I see. So next time, don't start right before you pick up your daughter.
I thought I'd be done fast. Usually they're done with the quizzes fast.
You never know. Our class is getting harder and harder.
I figured that out.
Okay.
I'll do it at nighttime.
Yeah, that's a good plan. Okay. So here, this is correct, but then this is not correct. So when you put the answer in your calculator, so be careful. And here, no product rule, because one of them is like a constant. So leave it there. Okay. And that's it. Any questions about the quiz? So you see, this quiz, we have more mistake than the previous quiz because our class is getting harder and harder. And you can see one example. We spent 15-20 minutes on just one example. It's really getting harder and harder. It's just the nature of the class. Imagine this is the last math class you have in college, right? You won't see me again. But I'll see you in the commencement, right? Yeah. Convocation. Oh, no. Commencement, right? Yeah. Okay. Yeah. All right. Any questions about the quiz? No? All good? Okay, so let's continue. Let me close that. So don't save. All right. So last time we talked about Lagrange multiplier. And 9.3 and 9.4, the main difference was 9.3, you have a surface and you want to find the maximum or minimum or saddle points of the surface in space. And 9.4, you have a surface and you also have a constraint. Okay, the constraint is a function on the xy plane. So for example, like this, look at the surface. If your constraint is a line, it's like you cut the surface and you get a curve, right? So you want to ask, within this constraint, what is the maximum or minimum of this curve? Or maybe your constraint is like a parabola in the xy plane. And then do you see it cuts the surface and then you get a curve like that? And then we want to find the maximum or minimum of this curve. Okay, so we're not looking for maximum or minimum of the surface. We have some constraint. Or you might have your constraint is like a circle. Then this circle, like a cylinder, you cut the surface, and this is the curve. And we're looking for the maximum and minimum of this curve. Okay, everybody? Yes, so that is the main difference of 9.3 and 9.4. We have a constraint. So then we have a curve in space. We're looking for the max and min. And last time we talked about gradients. Do you still remember the gradient vector? By the way, if you missed some class, make sure you watch the recording. Because every class, our knowledge based on the previous class. And we know the gradient is a vector field. So every point on the xy plane, you plug in this vector, you get a vector. That's why you see a lot of arrows there. And this gradient vector, it points to the direction where the f increase the fastest. And the magnitude of the vector is bigger if the f increase more rapidly. And if the magnitude, you see the arrow is small when the f increase slowly. Okay, so that's the magnitude of the vector. And also the vector is perpendicular to the level curves, right? Level curve, you cut it into so many slides using the horizontal plane, like z equals a number, and then you can see the gradient vector is perpendicular to the level curves. And last time we have the example. So usually you see two functions. One function is the surface. The other function is a constraint. So the constraint, you get an equation. So it represents a curve on the xy plane. So you have the surface and you have the constraint. You cut it, and then you end up getting a curve in space. You want to find the maximum or minimum. And last time we figured out that at maximum or minimum, we have the gradient vector of f parallel to the gradient vector of the constraint function g. Right? And that's why we spend a lot of time to figure out the Lagrange multiplier method. It's a system of equation, and you use the gradient of f equals lambda. Lambda is a real number, and multiplied by the gradient of g. Because those two vectors are parallel, they're either in the same direction or in the opposite direction, so they are scalar multiple of each other. And then we want to confirm our estimates. So we actually need to solve the system. So we have our function 3y minus x. That's the f. And the constraint g, and I told you the constraint g, you use the left-hand side minus the right-hand side. Because it's x squared plus y squared equals 1. So your left-hand side is x squared plus y squared, and your right-hand side is 1. So that's why your g is x squared plus y squared subtract 1. And gradient of f is you take the first partial derivatives. So derivative with respect to x is -1. Derivative with respect to y is 3. Right, everybody? And now we continue to find gradient of g. So that is gx, gy. Okay, what is the derivative with respect to x? Yes, 2x. And that's it, right? For the derivative with respect to x. How about the derivative with respect to y? Yes, 2y. Good. Now, look at this system. So this system, the gradient vector equals lambda times the gradient vector of g. What does that mean? Gradient vector of f is -1, 3, and that equals to lambda times the gradient vector of g, which is 2x, 2y. And then you have the constraint, g is 0. So you get x squared plus y squared minus 1 is 0. So this is what happens if we plug in those two equations. But the first one is a vector equation. And when you look at the vector equation, you look at each component respectively. Can you see we look at the first component? It tells us that -1 is lambda times 2x. Right, everybody? That's the first component. -1 is lambda times 2x. How about the second component? Three equals lambda times 2y. Exactly. And then the constraint, x squared plus y squared. We can put one to the other side, and it looks like nicer. Is that okay, everybody? So we get 3 equations. 1, 2, 3. This is a system of 3 equations. And how many unknown are there? We have x and y and lambda. How many unknown? 3, right? So 3 equations should be able to help us to solve 3 unknown. Okay. And then here, remember how to solve nonlinear equations. I teach you like 2 tricks. One trick is substitution. You're able to express some variable in terms of the other one, and then from the other equation. The second trick is vector. If you see like something, product of the two things equal to 0, then you set each vector equal to 0, and that's different cases. Do you remember that? So in this example, you can see we can express x in terms of lambda. And we can express y in terms of lambda. And then we can plug in the last equation. We only have one equation about lambda. Can you see that, everybody? So let's do that. So by the way, we do more examples, and then you kind of get the feeling what to do, how to solve the equations. Okay, so we express x in terms of lambda. So x is what? -1 over 2 lambda, right? We both sides divided by 2 lambda. And how about the y?
Um,
1 over?
3.
Yeah, 3 over 2 lambda. Yes, everybody? So we can then plug in equation 3. So x is negative 1 over 2 lambda square plus y. Y is 3 over 2 lambda square equals 1. So this is the substitution. Okay, express some variables in terms of the other one, and then you can plug in. So you get one equation and one unknown. You can solve for lambda. By the way, what is negative square? It becomes positive. What's 2 square? 4. And lambda square is lambda square. What is 3 square? 9. And then denominator? Yes. And that equals 1. Ooh. What is 1 plus 9? Yes. Great, everybody. What do we do next? Yes. So we both sides. We flip it or we multiply by 4 lambda square on both sides. Right? And then what do we do? Yes. Oh, what is 10 over 4? Yes.
And then from there we square it.
Yes. You mean square root?
Yes, root. Sorry.
Mm-hmm. And when we take square root, we get plus or minus. Is that okay, everybody?
Why do we do plus or minus for that?
Oh, every time you take square root, you do plus or minus. For example, if you have x squared equals to 4, because x could be 2, x could be negative 2. So every time you take square root, you get 2 roots.
That makes sense.
Yeah.
I guess I was confused because there's no like constant. You know, look at x and y on that side. So.
Oh, lambda is like a
oh, I guess that makes sense. Yeah.
Yeah.
Okay.
Lambda is the variable, right? Okay, so this is the lambda. And do you see we get like 2 numbers for the lambda?
So you get positive and negative.
Yeah, positive and negative. Okay, now let's see if the lambda is the positive 5 over 2. Our x is what? Let's see. I got negative 1 over 2 lambda. The lambda is what? Can I put like square root of 5 over square root of 2? Can I do that? And then this is the same as negative. Can you see the square root of 2 and the 2? You can cancel. So you have a copy of square root of, bless you, 2. Is this okay? Do you know 2 is square root of 2 times square root of 2? So you cancel one copy, you still have one copy left. So let me write down. So it's negative 1 over 2 is square root of 2 times square root of 2. And you have square root of 5 over square root of 2. You cancel one copy, so you still have one copy. Yes? And can we combine them? What is 2 times 5? 10. Yes. Okay, so this is x. Then what is the y? So you see the y is 3 over 2 lambda. And lambda is again square root of 5 over square root of 2. Yeah? And can we cancel the 2 and square root of 2? So you get a square root of 2 and square root of 5 in the denominator. Yes. everybody? And what is square root of 2 times square root of 5? 10. So we get 1 point. X is negative, bless you, 1 over root 10, and y is positive 3 over root 10. So this is when lambda is the positive, but if lambda is the negative, what happened? So if lambda is negative, you almost get the same thing, but what? A minus sign. So you just have an extra minus sign. So it just changed this answer from negative to positive, right? Everything almost the same. So you just have an extra minus sign. You can bring the minus sign in front. It will make this positive. Is that okay, everybody? Are you able to see that?
It's melting my brain. I'll get there.
So, because it's just different by a minus sign, so we don't.
It's not that. It was the trick you did with the 5 over 2.
Oh, okay. Let's see. Okay, how about I change to this way? So, are you able to understand why I can split the square roots to the top? That's okay.
Yeah.
That's the problem?
Yeah, that's the problem.
That's the problem. Oh, okay. I see. So
5 over 2 is the same as if you split it, right?
Yes.
Okay.
So we're using you mean a over b to the n is a to the n over b to the n.
Yes.
That's why 5 over 2 to the 1/2 is 5 to the 1/2 over 2 to the 1/2.
Yes.
And you square root of 5 over square root of 2.
Yes. Okay. Yeah. So I got that part. Now, how did you get rid of the 2?
Okay. So here, you know, 2 is like 2 to the 1/2 times 2 to the 1/2.
Yes. Okay. It that way.
How about 2? Okay. How about 2 is like 2 to the 1? Okay. So 1 is 1/2 plus 1/2.
Yes.
And a to the m times a to the n is a to the m plus n. Mm-hmm. So that's why it's 2 to the 1/2 times 2 to the 1/2. Okay. So you get square root of 2 times square root of 2. Okay. Or you can think of what is square root of 2 square. Yeah. That's 2. But square means it multiplies by itself. There's 2. Mm-hmm. Okay. So 2 is square root of 2 times square root of 2. Okay. So you cancel one copy of the square root of 2. Then you still have one copy. Or maybe I rewrite like this. So it's 1 over 2, and 1 over something is the same as you multiply by the reciprocal. Mm-hmm. So then you have the square root of 2 upstairs. That makes more sense. Okay. Yes. Okay. Yes. Right. Okay. Yes. You're welcome. So feel free to ask me, because during the conversation, I know which points that you don't understand. I can explain more. Okay, because I can explain all in different ways. I don't know how you learn all these tricks. You're like, oh yeah, just do it this way. Oh, after you do the calculation for the 10 years, 20 years, to get used to it. Okay. And you have your calculator, right? Do your calculator show you like square roots? Maybe? Because my calculator, I use the TIXX. Yeah, you have the fuller one. Yeah, when I type this inside and my answer, they will give me instead of decimal place, they will give me a exact answer. Yes. I'm not sure whether your calculator will give you exact answer. Okay, so this is 1 over square root of 10. Would that give you? Sorry, I gotta figure out how I'm gonna. All right. Okay. How about y? Do you see the difference is now we have a negative in front? So everything we were to say, so we will have a minus sign in front of the 3 over root 10.
Yeah, my calculator's not smart enough.
Oh, okay.
It just keeps telling me sit back there.
I see. Mm-hmm. Okay, so then the other point is we just change the minus sign, okay? So this is the other point. Is that okay, everybody? We get 2 points. And now, Lagrange multiplier tells us that you get your solution, right? Among all the solutions you get, plug into your original function f and find the f values. The largest will be the maximum, and the smallest will be a minimum. Okay, everybody? So we plug in f. Let's plug in f. So f of the first point, negative 1 over root 10, 3 over root 10, is, do you see f is 3y minus x? And 3y. Y, what is y? Y is 3y. What is y? Which one is y? Yeah, 3 over root 10. So 3 over root 10 minus, look at the function, 3y minus x. What is x?
Negative 1 over square root.
Yes. And do you see the denominator is root 10? And 3 times 3 is 9. And 9 plus 1, 10. Okay, can you tell me what is 10 over root 10? Look at this. What is 2 over root 2? So what is 10 over root 10?
You cancel them, right?
Yeah, we cancel them. So what do we get?
Is it just 1? No, because it's
So 10 is,
half times 10 on that, right?
yes.
1 is square root of 10. Okay.
Yeah.
So in a sense, you can just move it upstairs.
Right.
For that.
Yes. So we get cancel. And we get square root of 10. Or you can think of this way. You can think of this is 10 over 10 to the 1/2. So it's 10 to the 1 minus 1/2. So it's 10 to the 1/2. And it's square root of 10. You can also think of this way.
Yeah, because you would bring it upstairs. It becomes negative.
Yes.
Then you would
Add
take the
the
derivative. Wait.
no derivative. Add the exponents.
Oh, because you have 2. Okay.
Yes. So, and then we compute f of the other point, 1 over root 10, and negative 3 over root 10. So your y is now negative. And then your x is now positive. But do you see the denominator is still the same? Yes, everybody? And your numerator, what do you get? 3 times negative 3 is negative 9. Subtract 1. What is that? Negative 10 over root 10. So the answer is negative, you mean square root of 10. Yes. Which number is bigger?
The four, not the latter.
The top one, the positive one is bigger, and the bottom one is smaller. So therefore, we know, yeah, this is a maximum and this is a minimum. So, sorry, this is the maximum value. This is the minimum value. And then this point is a maximum. Okay, so usually they would say maximum value and minimum value is the function value. And then we have the The maximum and the minimum is the point. Okay, so f has the maximum at the points negative 1 over root 10 and 3 over root 10. And the minimum at this point. So this is our calculation. Does it match with our estimates? Look at this. We said we have a maximum when x is what? Here and y, okay, x is negative and y is positive, right? And let's see. X is negative and y is positive. Yes, see? X is negative, y is positive. And we have a minimum. Minimum here. What is this minimum? Like x is positive, but the y is negative, which is this point. X is positive and y is negative. Can you see our answer match with our estimates? Okay, let me ask you a question. In this problem, our solution, we get 2 points. So we can plug in and see which one is bigger, right? What if we only get 1 point? Then you don't have other point to compare, okay? So in that case, what you usually do is, so for example, like this picture, do you see you get 2 points? So you can find which one is maximum, which one is min. But like this picture or this picture, you only have 1 point, but then how do you know it's a maximum min? You pick any other point on your constraint and plug in your f to see if that number is bigger or smaller. For example, your constraint x squared plus y squared equals 1. You can find like any point, for example, 1, 0. Yeah, the easier point, you usually let either y is 0 or x is 0. So you have 1, 0. You can plug in the f to see whether that number is bigger or smaller. Okay, this is what happens if you only have one solution in the system.
What if your one solution is exponential, but it's still?
Huh?
What if your like one solution is like, something exponential, but the other part is 0?
What's exponential? Because your solution is like a point.
Just continually going up infinitely.
Then you don't get any solution.
Okay.
If you get a solution, you reach either maximum or minimum.
Okay.
Yeah. Okay. So that's one example. Wow. See, our problem is getting harder and harder. We spent what?
What is our next test going to be? 3 questions?
5. Yes, because some problems are easier, some problems are harder. Yes. Okay, we don't have time to talk about the next one. So, but you understand the idea. You set up the system and you compute the gradient of f, the gradient of g, and then you need to solve the system of equations using the algebra techniques. So here you gotta practice more problems. And before you go, I want to show you. I realized my notes is I use different methods. So I want to explain to you the other methods. So here. So what we do, we express x and y in terms of lambda. The second way to do this is to eliminate the lambda. Do you see we use equation 2 over equation 1? We can get rid of the lambda. We get a relation between x and y. You see, I can express y in terms of x. And then we can plug in the third equation. You get directly x is plus or minus 1 over root 10. And then your y is negative 3 times x. You get the y is negative positive 3 over root 10. We get the same answer. So this is a different way to solve the system. Which way do you think is easier? This one, yes. Right. So there could be different ways to solve a system of equations. Yeah, it really depends on the problem.
This problem works this way, works better.
Yeah.
Like that one works better than elimination or the substitution.
Right. Yeah. Okay, so study session this afternoon. I also have office hours from 11 to 1:50. So feel free to ask me questions. Exam Monday. Have a nice weekend.